Hi everyone. In this video we shall see the topic central limit theorem. Central limit theorem, we know that the mean of the sampling distribution of the mean will be equal to the population mean. As the sample size increases, the sampling distribution of mean will approach the normal distribution. Now the relationship between shape of the population distribution and shape of population distribution of mean is called the central limit theorem. When the sampling is done from a population with mean mu and standard deviation sigma, the sampling distribution of the sample mean x bar will tend to a normal distribution whose mean value will be mu and the standard deviation will be sigma by root 10. Now, for large enough, that is as n becomes very large, the mean x bar tends to the normal distribution, that is n of mu comma sigma square by n. The significance of central limit theorem is that it permits us to use sample statistics, that is mean, variance, etc., to make inferences about population without knowing anything about the shape of the frequency distribution of that population other than what we can get from the sample. Now let us see a problem based on application of central limit theorem. The problem is the lifetime of a certain brand of an electric bulb may be considered as a random variable with mean 1200 hours and standard deviation 250 hours. So here the mean value mu is given as 1200 and standard deviation sigma value is 250 hours. Let us choose xi be the lifetime of an electric bulb. So we have the mean x is equal to x1 plus x2 etc. up to x60 by 60 since the sample size n is 60. Now by central limit theorem, the mean x bar approaches the normal distribution n of mu comma sigma square by n. So we have p of x bar greater than 1250 is equal to p of x bar minus mu by sigma by root n, which is greater than 1250 minus 1200 by 250 by root 60. Now the value x bar minus mu by sigma by root n can be replaced by z. So we have p of z is greater than 1.55, which is rewritten as zero point 0.5 minus p of 0 less than z less than 1.55. From the normal distribution table, we get the value of p of 0 less than z less than 1.55 as 0.4394. So we have p of x bar greater than 1250 value is 0.0606. Let us move to next problem. A random sample of size 100 is taken from a population. So here the sample size is 100 means n value is 100. Now the population with mean value is 60 and variance is 100. So here the given value of mean and variance are for the population. So we have mu value is 60 and sigma value is root 400 because variance is given. So sigma means root of variance, that is why root 400, which is equal to 20. Now x bar is the sample mean. So our required probability is p of minus 4 less than x bar minus mu less than 4, which is equal to, here replace mu by 60. So we have p of 56 less than x bar less than 64. Now using the standard normal variate, we have p of 56 minus 60 by 2 less than x bar minus mu by sigma by root 10 less than 64 minus 60 by 2. So which is equal to p of minus 2 less than z less than 2. Now instead of finding the negative side, we can replace it by positive side for of the normal curve. So we have 2 times p of 0 less than z less than 2. Now the value of p of 0 less than z less than 2 from normal distribution table is 0.4772. So we have the probability value as 0.9544, which is the required answer. Now let us see one more problem using the application of central limit theorem. The problem is an economist wishes to estimate the average family income in a certain population. The population standard deviation is given to be $4.5. So it means the population standard deviation is denoted by sigma. And the economist uses a random sample of size 225. So n value is 225 And now we have to find the probability that the sample mean will fall within 800 of the population mean. So population mean is given as 800. It means mu value is 800. Now x is our x bar is our sample mean. So by central limit theorem we have x bar approaches n of mu comma sigma square by n. So the required probability is P of minus 800 less than x bar minus mu less than 800, which is equal to, by proceeding, we have P of minus 2.67 less than Z less than 2.67. So in the normal curve, again the negative side, instead of calculating the negative part, it is enough to find the positive part. So we have 2 times P of 0 less than Z less than 2.67. Again using the table value, P of 0 less than Z less than 2.67 can be found as 0.4962. So the probability value is 0.9924, which is the required answer. Thank you.